Okay guys, in this video we want to check out just a couple different ways to find the equation of a line. Hopefully this is review for you. If not, we'll go through the process and try to get you where you need to be. So we just want to look at a couple examples. So the first example, we want to use the given information to find the equation of the line. The line has a slope of negative 2/3, so I know that that's usually m. And then it also passes through this other point. And notice that this other point is not the y-intercept. It'd be nice and easy if we could go ahead and use this, y equals mx plus b. And that's the thing that we're most familiar with because we have the slope, but we know we don't have the y-intercept. So we're going to have to go through that process to find that piece of information. Okay, so I don't have the y-intercept, but I do have an x and a y. So wherever I see x, I'm going to plug in 3. Wherever I see y, I'm going to plug in negative 2. So let's go ahead and go through that. So I know negative 2, and I'm just plugging right into this equation up here. I know negative 2 is equal to negative 2/3, and then times x plus b. And b is the variable. Remember, this is the y-intercept. We need to solve for the y-intercept so that we can then go back and write our equation with a general x and a general y and plug in our slope and intercept. So we're using all the info that we have. We know the slope, we know an x and a y, and we're plugging that information in. Let's go ahead and simplify here. I've got negative 2. I know this is really 3/1, so when I multiply, I'm going to multiply across and get negative 6/3, which just simplifies to negative 2. And that's plus b. So when I add 2 here, add 2, I'm left with 0 equals b. And so this is actually a little bit of a special line. The y-intercept is actually 0. So I can write the equation of my line now, and it looks like this. Y equals negative 2/3 x plus 0. And you and I both know that we don't have to write the plus 0, so this is my answer. So what I really want to show you guys today is that this is in slope-intercept form. It's y equals mx plus b. But it's actually not the easiest way to come up with the equation, a valid equation for a line. And the reason being because I don't really like going through this process. We got to plug a bunch of numbers in and simplify, and it's easy to make a mistake. And so I want to show you a different form. And the first thing that I want to show you is this is called point-slope form. And just like slope-intercept form, the name kind of gives away what information is given in the equation. So the first thing is the general form of the equation is, let's say if we have some point and that point has coordinates x1 and y1, just like up here. So in this particular case, my x1 would be 3, my y1 would be negative 2. We can have any general point with an x coordinate and a y coordinate. So the form of this, or what this point slope form looks like, is I take a general y and I subtract whatever the y coordinate of my point is, so y1. And that's equal to the slope times my general x minus the x coordinate of my point. And this is a completely valid form of a line. So I want to look back up at the original problem. The original problem, we know that the slope is negative 2/3. And it also passes through this point 3, negative 2. And literally all we have to do is plug these numbers into this equation and we're done. We have the slope of a line. So we don't have to write the slope. If it asks you for the equation of the line, you don't have to write it in the slope-intercept form. This point-slope form is another way to do it, and a lot of times it's a lot easier. So all I'm going to do is I'm going to plug into this equation. Remember, this is my x1 y1. So my general form of my line in point slope form is going to look like this: y minus the y coordinate of my point. And again, plug in with parentheses always, equals the slope in parentheses x minus the x coordinate of my point. And then simplifying, I get y plus 2 equals negative 2/3 x minus 3, and I'm done. So this is the equation. So the last thing I want to show you is, hey, isn't that a different equation from what we get up here, from y equals negative 2/3 x? Well, let's check out what happens when we kind of expand on this. And we don't have to do this, but when we expand on this, the first thing that we would do is to distribute. So all we're doing is kind of checking to make sure that these equations are the same thing. So I'm going to distribute this negative 2/3, and I'm left with y plus 2 equals negative 2/3 x, and then distribute it to that, plus 2 times 3 is going to be 6, divided by 3 is 2. And look at what happens. I'm going to subtract 2 from both sides to try to compare form, so I have y equals for both of them. Minus 2 and minus 2. And when I simplify this, it gives me the exact same thing, which is great. So the point of all this, guys, is these are just two different forms. Point slope form is a different way of writing the equation of a line. A lot of times it's a lot easier if you have any general point in the slope. You can just plug it right in, and there's not really a whole lot of work to do. This is also the equation of a line. This is slope-intercept. And it's just the same, it's the same line written in two different ways. So let's get a little more practice working with point slope. So one more time, we've got slope equals 4/5, and my point is negative 5, 1. So this is just my x1, y1. That's just the coordinates of my point. And literally, I want to write the equation of a line, and it is this quick. All I have to do is remember that point slope looks like this. Y minus y1 equals m times x minus x1. Or I can do y equals mx plus b. Those are two valid options. But since I have the slope and I have a point, why not just put it into point slope and be done with it? There's a lot more work to do. Remember all this work that we had to do in order to find the y-intercept on this last example. We don't need to do all that work with point slope if we have the point and the slope. So let's check this out real quick. I'm just going to write the equation of this line. I need y minus, and my y1 here happens to be 1. That's the y coordinate of the point that I have that I can work with. And that's equal to the slope. I know that's 4/5. That's given straight away. Times the quantity x minus the x coordinate of the point that it passes through. And that happens to be a negative 5. So that turns into a minus, a negative turns into a positive, and I'm done. That's it. I've got the equation of my line. No more extra work to do, and that's that. So the next couple examples we're going to look at, if you noticed in the last two, we were given the slope, and in the next couple we've got to find the slope, and then the process is really pretty much the same. So I want to find the equation of a line that passes through these 2 points. And if you notice in slope-intercept or in point slope, we need the slope either way. We've got to have the slope of that line. So I'm going to go find the slope of that line. And if you remember, the slope of any line, most of you, if I ask you what the slope is, you say it's rise over run. Well, what does that mean? All that means is we're trying to find the change in the y. So the change up and down, that's what they mean by rise. So we do that by taking the second y and subtracting the first y, and that gives us how far we traveled in the y direction. And then the run is just left and right. It's how far do we go left versus how far do we go right. And that's the x coordinate of where we ended up minus the x coordinate of where we started. So In order to find the slope, we're going to use this slope formula, they call it. But really, we're just trying to figure out how far do we travel in the x and how far do we travel in the y. So let's go ahead and label these. So if I look at my points, I'm going to call this the first point, that's x1 and y1, and I'm going to call this the second point, and that's x2 and y2. So when I do that, I've now given myself the ability to easily just kind of plug in. And you don't have to label these. We're really just looking at, we end up at -3, and we subtract 1. So in the numerator, to figure out how far we traveled in the y direction, I take this y value and subtract this y value. The y value of the second point minus the y value of the first point. And then I do the same for the x's. So I look at the second x coordinate, that's -2, and I subtract the first x coordinate, which happens to be -5. Now we want to simplify this. That gives me -4 over, this is -2 plus 5, minus a negative turns into a positive. So that's -4/3 is my slope. So I now have the slope, and I've also got 2 points. And notice I don't have the y-intercept. I've got a point. So which one is going to make more sense to use? Well, point slope is. And we can actually use either one of these points. And let's just go ahead and plug in real fast. If I use the first point and plug it into point slope, I know that's y minus y1. Well, y1 happens to be 1 equals the slope times x minus a -5, which turns into a +5. So this is a perfectly valid equation of this line. I could also plug in this point over here. It doesn't actually matter what point I plug in. So I'm going to take my y and subtract my y value here. So that turns into a minus a -3, turns into a positive. The slope stays the same. And it's always the slope times the quantity x minus the x value of the point. So minus a -2 turns into a +2. And if we would go and expand these actually are the exact same equation. If we want to put them in a slope-intercept, those are the exact same equation of this line. So just to make sure that you're convinced, let's go ahead and we'll just kind of check it. I'll do it real fast on here. So I've got y minus 1 equals -4/3 x. I'm going to distribute this -4/3, and that's going to be minus 20/3. And then if I want to solve for y, I get 0. And this is, I'm going to change this into a fraction so that I can then combine it over here. This is minus 3/3. That's exactly the same thing. And if I want to get rid of it, then I want to add 3/3. So add 3/3 to both sides. So I'm left with -4/3 x, and that's -20 plus 3, because we're adding the numerators. That gets me minus 17/3. So let's go over here and see if we get the exact same thing. So we're going to distribute. So we've got y plus 3 equals -4/3 x minus, there's my -4/3 x, and I'm going to end up with -8/3 on the right side here. Again, I want to get a common denominator, so this is actually plus 9/3. It's equivalent to 3. And if I want to cancel these, I'm going to subtract it, so minus 9/3. And if we simplify, we're going to be left with y equals -4/3 x. -8 minus 9 gives me -17/3. Absolutely, it is the same exact equation. Whether we plug in the first point or the second point doesn't really matter.